Hello, welcome back to another exciting session in chemistry. This is Mr. Mweso from Cashford Tuition Center, and I'm one of the Maford writers. Let's look at the first topic in chemistry, which is none other than the atomic theory. We understand that the atomic theory is simply a theory which looks at the different concepts of or theories which have been brought up concerning atoms. At grade 12 level, it is simply basic. So this is strictly for grade 12 syllabus. So let's continue. We're going to look at what an atom is. An atom is simply the smallest particle of an element that can take part in a chemical reaction. That smallest particle of an element that can take part in a chemical reaction is what we're calling an atom. Now, we have to understand that an atom is made up of two parts. We have the nucleus and the orbits or the energy levels. Now, we'll look at the nucleus first. What is found in the nucleus? So when we're looking at the nucleus, we have to understand that the nucleus is found at the center of an atom and comprises of two subatomic particles, namely proton and neutrons. So we are saying the nucleus comprises of protons as well as neutrons. So if we understand that, we can move on to discuss these subatomic particles which are found in the nucleus. So when we're looking at the proton, protons are simply positive subatomic particles of an atom. So we are saying protons are positive subatomic particles of an atom. Now when we're looking at neutrons, from the word neutral, neutrons are simply neutral subatomic particles of an atom. Now, in chemistry, we have to understand what is known as the proton number. The proton number or atomic number. Now, in the nucleus of an atom, when they are looking at the total number of protons in the nucleus of an atom, we call it the atomic number or proton number. So atomic number is the total number of protons in the nucleus of an atom. So when we have any nuclide of an atom, the number which is found beneath the chemical symbol is what we are calling the proton number. Then we can move on to look at what is known as the mass number. Mass number or nucleon number or the relative atomic mass, that is one and the same thing. Now what is it? It is simply the total number of protons and neutrons in the nucleus of an atom. So we're saying the mass number, nucleon number, or relative atomic mass, it is simply the total number of protons and neutrons in the nucleus of an atom. So you see from what we've done, the nucleus is a vital part of any atom. Yes. So now we look at the energy levels. The energy levels or orbits, they surround or they orbit around the nucleus. Now, what do we find in the energy levels? We find electrons. Now, what are electrons? Electrons are simply negative subatomic particles of an atom. Electrons, negative subatomic particles of an atom. That is what we're calling electrons. Now we have to understand that when we're looking at this particular atom, an atom has the same or an exact number of protons and electrons. So we are seeing the positive charges are equal to the negative charges. Thus we can conclude to say atoms are electrically neutral, or they have a charge which is zero. So all atoms have a charge which is zero. Why? Because the number of protons is equal to the number of electrons. So we can move on. we can look at what is known as the electronic configuration. Now, what is an electronic configuration? Electronic configuration is simply that representation of the arrangement of electrons in the orbits of an atom. So when we're looking at the manner in which electrons are arranged in the orbits of an atom, then we're looking at the electronic configuration of a particular atom. There are certain rules we have to follow, but first we need to know that the number of electrons in a particular shell is given by 2n to the power 2, where n is the number or the shell number. So we're saying in the first shell, our n value will be equal to 1. So the maximum number of electrons in the first shell will simply be 2 multiplied by 1 square. So this is giving us 2. So the first shell can hold only 2 electrons as its maximum. So it can have 1, but it cannot exceed 2. Then when we look at the second shell, we'll have the same basic formula. We're saying 2, where we have n, we're going to put 2. 2 to the power, 2 times 2 is 4, so which is giving us 8. So the second shell will have a maximum of 8 electrons. So it can have less than 8 or equal to 8. Then the third shell will have 2, 3 to the power 2, which is giving us 9. 9 times 2 is 18. So the third shell will have a maximum of 18. Though in our syllabus, at grade 12 level, we only look at the first 20 elements. So I would advise the third shell will be using a maximum of 8. Take note of that. Why? Because we deal with the first 20 elements on the periodic table. Now, for us to know how to look at the electronic configuration, we have to know what a period is, as well as a group. Now, when we look at the periodic table, we have to understand that the period is simply that horizontal arrangement of electrons or elements on the periodic table. So when we look at elements in the first period on the periodic table, we have hydrogen and helium. Those are in period 1. Then the second period, we have lithium and the other elements. And third period and fourth period where we have potassium, which is the last period you'll be dealing with. So period will tell you the number of shells a particular atom will have, or the number of electronic shells which an atom will have is related to the period. If it is in period 1, it will have 1 circle. Period 2 will have 2 circles. Period 3, they will have 3. Period 4, where we end, they will have 4 shells. Get that, and you find chemistry to be very easy. Let's look at a group. A group is simply that vertical arrangement of elements on the periodic table. Now we have basically 7 groups. We have 8 actually, because group O is inclusive. So we'll say we have group 1 to 7, then we equally have group O, which is 7 groups. So that vertical arrangement of elements on the periodic table, vertical meaning up and down. And in group, we have group 1, group 2, group 3, group 4, group 5, group 6, then we have group 7, then group O. So we have these basic groups. So all elements in group 1 will have 1 electron in the outermost shell, meaning you know that in the last shell you have 1. In group 2 you have 2. Group 3 you have 3. Group 4 to be 4. Group 5 it will be 5. Group 6 6. Group 7 7. Group O we have 2 cases, so I will not talk about them now. But we have some which only have 2 and others who have 8. We will not talk about that for now. So that's, we are saying the group is simply telling us the number of valence electrons, or the number of electrons in the outermost shell, which is the valence electrons. Okay, now let's try to draw or to come up with the electronic configuration of hydrogen. Hydrogen is the first element on the periodic table. If you are looking up elements on the periodic table, you look at the proton number, which is the figure below, the chemical symbol. So hydrogen is in period 1, so it will have 1 dash. So since it only has 1 electron, you can just put 1. So the hydrogen, when you want to draw it, it will simply be like that. Then when we look at helium, He has 2. It is in a group O, but it is in period 1, meaning it will have 1 dash. So first shell holds up to a maximum of 2. So first shell, so it's having 2. That's helium. Then we can look at potassium. Potassium, even if we don't know the number which potassium has, I presume it's 19. It is in period 4, so we'll put 1, 2, 3, 4. Now potassium is in group 1, so meaning the last shell will have 1 electron. So let's look at the first shell. For it to be full is 2. Second shell it is 8. Third shell it will equally be 8. Let's try to add if it's given us 19. 2 plus that is 10, plus that 18, plus 1, 19. So for potassium, it is given us that. We started by knowing first the period has 1, 2, 3, 4 dashes. The group, it is in group 1, so last shell 1. First shell, for it to be filled, maximum is 2. Second shell, for it to be filled, maximum 8. Third shell, I said since we're dealing with the first 20 elements, we'll be using 8. That's why we've placed 8 there. So we can draw potassium. The first shell will have 1, 2. Second shell, we have 1, 2, 3, 4, 5, 6, 7, 8. And the last shell, we are having 1. So that's how we write the electronic configuration for potassium. Are we clear? So I'm sure you're getting to understand what we're dealing with. I'll give an example of oxygen, then we'll look at ionization. So the last example I'll give is the electronic configuration of hydrogen. Okay, so we continue from where we left. We're trying to look at the electronic configuration for oxygen as well as the electronic structure. Let's look at oxygen. Oxygen is in period 2 of the periodic table, and it is the element number 6 on the periodic table. So since it is in period 2, we're going to have 2 circles. So in drawing the structure of oxygen, we have 2 shells. Now, oxygen is in group what of the periodic table? Oxygen is in group what? It's in group 6. Actually, oxygen has 8. So it is in group 6, so meaning last shell it will have 6 electrons. The first shell, for it to be filled, has to have 2. So oxygen has 2, 6. So first shell will have 2. Second shell will have 1, 2, 3, 4, 5, 6. This is how we draw the structure of oxygen. Isn't it too easy? I'm sure you're getting to understand that it is very easy to draw these structures. What if we want to write the electronic structure of calcium? Calcium has 20 and is in group 2 of the periodic table. Let's look at calcium. It is in period 4, group 2. So since it's in period 4, we have 1, 2, 3, 4. So when we want to draw the structure of calcium, first shell, second shell, third shell, and the last shell. Now we are saying it is in group 2, so meaning the valence electron will be 2, or it will have 2 electrons in the outermost shell. Now for the first shell to be filled, maximum 2. This one is also full, so we simply put 8 because group 2 are period. The second shell and the third shell have a maximum of 8, as we alluded to earlier. So we can now draw the structure. We have 2, which is this one, comma 8, 1, 2, 3, 4, 5, 6, 7, 8, comma 8, 1, 2, 3, 4, 5, 6, 7, 8. Then the last here we have 2. This is how we draw the structure of calcium. Now, we have to understand what is known as ionization. Ionization is simply the process by which an atom becomes an ion. That process by which an atom is becoming an ion is what we're calling ionization. Let's say, what is an ion? An ion is simply a charged atom. So when an atom is charged, we say it is an ion. So atoms can either have a positive charge or a negative charge. These positively charged atoms are what we call cations, whereas the negatively charged ions are known as anions. So we're saying we have 2 types of ions. We have cations, which are positively charged atoms, whereas ions are simply negatively charged atoms. Are we clear? Yes. So now, when we look at metallic ions, they are cations. So all metals will have a positive charge when they become ionized, whereas non-metals will have a negative charge when they become ionized. Let's look at calcium here. When calcium wants to become an ion, since it's in group 2 will have a positive 2 as a charge. Why? Because it will lose 2 electrons. When it loses 2 electrons, meaning the protons will be exceeding by 2. That's why having plus 2 for the metals or for calcium. Are we together? So when we want to draw calcium ion, the way we drew calcium, which is atom, we rub or we remove the valence electron, meaning calcium ion will be drawn in this manner. So for the metals, we'll be erasing the last circle or the valence shell. So we'll have that to be calcium. We put the positive 2. Others can write 2 plus. It's one and the same thing. So that's how we write calcium ion. Then the anions, like oxygen, for it to become stable, it needs 2 electrons to stabilize. Because in the last shell, it has 6. Now it needs 8 for it to reach its maximum. So it will get 2 electrons maybe from another atom, meaning you have 2 different electrons. So we'll not use dots, we'll use crosses to show that these 2 electrons are coming from a metal. So these 2 crosses. So with this, the electronic configuration for oxygen ion is 2,8. But we'll represent this as 2 negative. Why? Because the number of electrons have exceeded by 2, meaning it will have 2 negative. That's how we deal with ionization. I'm sure you're getting to understand what ionization is and the 2 types of ions which are found in chemistry are the positively charged ions or the metallic ions, which are the cations, whereas are the non-metallic ions, which are the negatively charged ions, known as anions. So if you understand that, I'll talk about the last thing in this segment, which is none other than isotopes. So isotopes are atoms of the same element having the same number of protons but different number of electrons. First definition, we're saying isotopes are atoms of the same elements having the same number of protons but different number of electrons. Oh, neutrons, I mean. So we have X having maybe 20/6. Then we have Y having 6, then 21. So when we look at these 2 elements, when we want to calculate the number of neutrons will simply be equal to the mass number, which is 20, minus the proton number, which is 6. Why? Because I was saying proton number is simply the number of protons, then mass number is the number of protons and neutrons. So this is giving us 14. Then this one, neutrons for atom 2 will be 21 minus 6, which is giving us 15. So when you look at these, they are having the same proton number because we have 6 here, 6 protons, and the number of neutrons is simply 14. This one is having a proton number, which is 6, but the number of neutrons is 15. So the atoms of the same elements having the same number of protons, but different number of neutrons, we are calling them isotopes. We can also define in terms of proton number and mass number. We can say isotopes are atoms of the same element having the same proton or atomic number, but different mass numbers. So those are the definitions we need to know in this particular segment. So with you here was Mr. Mweso, and we have understood how to write the electronic configuration and to look at the key definitions under atomic theory. I'm sure you enjoyed, and I advise you practice, and next time ensure that you have a periodic table beside you as you are learning. Au revoir.